Hello students, so we will continue with dimensional analysis. I hope you have revised how to find the dimensions of any physical quantity. Various physical quantities can be of two types, variables or constants. Variables can have dimensions or it need not have dimensions. Similarly, constants can have dimensions, it need not have dimensions. Let us see. First we will go to variables having dimensions. This you know very well. Velocity, acceleration, force, pressure. We have found the dimensions of these physical quantities. So these physical quantities are called dimensional variables. Now let us try to see constants who have dimensions. This also we studied to some extent. We have studied for velocity of light is meter per second. Gravitational constant G, we have found its dimensions. Planck's constant H, we found the dimensions by the using appropriate formula. So these are called constants having dimensions. So they are called dimensional constants. Now let us try to see variables which do not have dimensions. Simple example is strain, which we did last time. Strain is delta L upon L. Strain is delta L upon L. Both will be measured in fundamental quantity L, so they will cancel. So it has no dimensions. Angle theta in radian, whenever we say angle theta, it means it's radian, is arc length upon radius. Both are measured in length, so they will get cancelled. So it does not have dimensions. Okay, so these are called dimensionless variables. Now non-dimensional constants, you know, pi and integers 1, 2, 3, 4, e and all those things are non-dimensional constants. So there are four types of physical constants: variables, dimensional, non-dimensional, constants, dimensional, non-dimensional. Now we will learn very important principle called principle of homogeneity of dimensions. It means like we always have an equation, left hand side equal to right hand side. Each side may have two or more terms or even single term, but in case it has two or more terms, then all terms should have same dimensions. Like you cannot add kg and second. You cannot add any two quantities of different type. So the dimensions of all the terms of right hand side should be same, as well as it should be equal to dimensions of all the terms of left hand side. So if that is true, so this is called homogeneity of dimensions. It cannot happen that left hand side one term has got different dimensions. This should be clear when we see various examples. Like this equation of motions we have studied, v is equal to u plus at. So what is dimension of v? Velocity, Lt raised to minus 1, u Lt raised to minus 1, at, dimension of a is L, t raised to minus 2, and then further t, so this will give me t raised to minus 1. So it will become L into t raised to minus 1. So all dimensions of each term on both the sides are same. This is called principle of homogeneity of dimensions. Okay. Now I will explain you few examples to illustrate the use of principle of homogeneity of dimensions. The first example reads, find the dimensions of A cross B. So means we have to find the dimensions of A and B and multiply them, where the relation given is P is equal to B minus x square upon AT. P is power, x is distance, so it will measure in length. A we have to find out, T is time. So its dimension is capital T. So now first let us find dimension of B, as x square dimension is L square, by principle of homogeneity, dimension of B is also x square. So we have found that dimension of B is x square. Okay, now we want to find dimension of A. So to find dimension of A, we will take A on other side. So what I will get? A is equal to numerator dimension is L square. Okay, upon T dimension is T, and P will come here. So I am writing P here. So dimension of P we know. We have found out in a few other cases. It is m L square T raised to minus 3. Put the dimension of P and then do the simplification. You will get dimension of A as m raised to minus 1 T square. So this is the dimension of A. So dimension of A cross B would be m minus 1 T square, and B was x square, L square. So you will get m minus 1 L square into T square. So that is the dimension of A cross B. Now we will do this second sum, van der Waals equation. P plus A upon V square into V minus B is equal to RT. So now what will be dimension of B? So dimension of B would be dimension of V. What is dimension of V? L cube. So dimension of B is L cube. So I found out dimension of B is equal to L cube. Okay. Then we have to find out dimension of A. Now by principle of homogeneity, dimension of P would be equal to dimension of A upon V square. That's what I have written here. Dimension of P is equal to dimension of A upon V square. So dimension of A would be dimension of P into V square. Dimension of B is L raised to 3. So dimension of V square would be L raised to 6. Dimension of P we have already used here. So we'll put the dimension of P into L6. I will get dimension of A, which I have got as m into L raised to 5 T raised to minus 2. So this is dimension of A. And then in this question he is asking SI units of A and B. So SI units of B, what was the dimension of B? L cube. So SI unit would be meter cube. What is dimension of A? M L raised to 5 T raised to minus 2. So its SI unit would be, in place of m we will write kg, m raised to 5 s raised to minus 2. So this is my unit of A. Or once you know the dimensions, giving unit is not difficult, and if you know the units you can find the dimensions. Now next one is check the correctness of the equation. V square minus U square is equal to 2AS. Now dimension of V and U would be same, both are velocities. So L into T raised to minus 1. Dimension of A is L into T raised to minus 2. Dimension of S is L. So dimension of AT would be L square into T raised to minus 2. And the same is dimension of U square and V square. V square and U square dimensions are same. So this equation is correct as dimensionally. So we will say equation is dimensionally correct because each term is having same dimensions. Okay. So then we will go to, now we will use dimensional analysis to convert from one system of units to other system, like SI system to CGS or vice versa, or some new type of systems which are given to us. So we have learnt in previous classes that N1 U1 equal to N2 U2. Like I had given you example, like so suppose I got 5 kg. So you will say 5 kg is equal to how many grams? 5000 grams. Quantity is same. So if we are converting kg to gram, number is changing. So similarly, N1 U1 equal to N2 U2, we will be using this formula in our deriving the theory. Now, in case I have got a physical quantity, okay, mass is dimensional is A for mass, for length it is B, and for time it is C. So what I can say, my dimension of this physical quantity would be m raised to A, L raised to B, T raised to C. Now I have got two system of units. Now dimensions does not depend on unit. Now so the P would be equal to N1 into M1 raised to A, where M1 is mass in system 1, L1 raised to B, T1 raised to C. So system is 1. Then another system of measurement is 2, like 1 can be CGS, 2 can be SI system. So here number is N2 and M2 raised to A. So A, B, C would remain same because dimensions are remaining same. So from here, if I equate the 2, N1 is 1 equal to N2 root 2, then I will get N2 is equal to N1, see, listen carefully, N2 is equal to N1 into M1 upon M2 raised to A, L1 upon L2 raised to B, T1 upon T2 raised to C. This is N1, then U1. Therefore, here it come M1, L1, T1 because this is N1. And this has come from here. So, this formula you should learn. So, we are finding the value of N2. So, means the system in which we want to find the value, that is N2, and its parameters, its system units will come here. And this is which is given to us. We'll do some, it will clear to you. He says convert SI unit of force. Force in SI system is Newton. So this I want to convert into CGS. CGS unit you know is dynes. So you know the answer, 1 Newton is 10 raised to 5 dynes. Let us convert and try to see and know the method. So we will use this formula. N2 equal to N1 into M1 upon M2 raised to A, L1 upon L2 raised to B, T1 upon T2 raised to C. And the unit of force are, dimensions of force are M1, L1, T raised to minus 2. So my A is 1, B is 1 and C is minus 2. So I know ABC. I know my N1 in SI system, my force is 1 Newton. And as I told you, this is N1, so here would become system values of this N1. So N1 is an SI system, which I know. N2 I want to find out, so they will be, that will be in the denominator. This is N2. So this is kg, meter and second. Denominator would be gram, centimeter, second. Now this is 1 kg is 1000 gram, because then only I can cancel, so I will get 1000. 1 meter is 100 centimeter, I will get 100, and time will get cancelled, both are S. So 1000 into 100 will give me 10 raised to 5 dyne. This is how I can convert from one system to another. Is it all right? You can revise this for 2 minutes. Then we will do next sum. On next sum it says 1 meter, 1 kg and 1 minute. They are taken as fundamental units. Now I am changing my fundamental unit, but length and mass are remaining same, time I am changing. The magnitude of force is 36. So this is the magnitude of force in this system. So this would be my 1. So my N1 would be 36, M1 would be 1, L1 would be 1 kg and time would be 1 minute. And for 2 I want to calculate in CGS. So N2 I want to calculate, N2 is equal to, here will come CGS. So CGS means here will come gram, here will come centimeter, here will come second. This is kg, meter, minutes, and this 36. Because I want to calculate for this 36 in the new system how much is in the CGS. So this 36 will remain like what we did before. 1 kg is 1000 gram, 1000. 1 meter is 100 centimeter to 100, and 1 minute is 60 seconds. So 60 upon 60 SS will get cancelled, but raised to minus 2. So 1 upon 60 into 60. If you do this calculation, you will get 3600. You will get 1000 dynes, because the 60 and 60 will get cancelled with this 36. So you will get 1000 dynes. Is it all right? Let us do some more sums. In this sum, he says 1 calorie is for 4.2 joule. So you know joule is a system in SI system. So 1 joule is 1 kg meter square h raised to minus 2. So from here, if you want, you can also calculate dimensions. It would be m L square T raised to minus 2. So but he has given. Suppose we have a system of units in which mass is in, now we are going to other system. Mass is alpha kg, length is beta meter, and time is gamma second. So what is magnitude of calorie? Calorie means 4.2 joule. So means I want to find equivalent number to 4.2 joule. So whatever that number I get, that is equivalent to 4.2 joule, means it is equivalent to 1 calorie, because 1 calorie is 4.2 joule. So my N1 is 4.2. So my N1 is 4.2. Length is 1 kg, because this is SI system. Sorry, mass is 1 kg, length is 1 meter, time is 1 second. And N2 I want to calculate. M2 is alpha kg, L2 is beta meter, T2 is gamma second. And A is 1, B is 2, and C is minus 2 time. So I know all this value. To substitute in this formula, you will get the value of N2 as 4.2 into alpha raised to minus 1, beta raised to minus 2, gamma raised to 2. So you will get this answer. So that is 1 calorie. Okay. Now let us do one more sum. He says units of force, energy and velocity are given. So force is measured in 20 Newton. Energy is in 200 joule, and velocity is 5 meters per second. So these are my now new system. Force is this 20 Newton, normally force is 1 Newton, energy is 200 joule, and velocity is this. What will be the value of length, mass and time? So if these are my fundamental, what would be length, mass and time? So now in this case when 3 are given, so I know force is equal to, write the dimension of force, that is 20 Newton. Energy, write its dimensions, it is 200. Velocity, write its dimensions, it is 5. Now, so I have got 3 equations with 3 unknown. Solve, you will get the value of m, l and t. So how I have done? I have divided the second equation, because second equation m1 L square T raised to minus 2 upon m1 L1 T raised to minus 2. So I will get value of L as 10. Only L will remain. Now put the value of L in this third equation. Put the value of L here, you will get the value of T. So T you are getting 2 seconds. Now you know L and T, you put here, you will get the value of M as 8 kg. So this is how you can convert from one system to other system. Is it all right? So this topic is over. Now we will do how to make equations involving the various physical quantities. We will be trying to build up the relation between physical quantities. That is the next topic. Okay. Thank you.